Today we're going to look at odds, which is very closely related to probability. Let's first understand the complement of an event in full. So example, consider the event A rolling an odd number on a die. So here the probability of A is 3, and that's 3 because there are 3 ways to get an odd number, and that would be rolling a 1, a 3, or a 5 over the total number of sides on a die, which are 6. So there's a 3 in 6 chance, or a 1 in 2 chance. The complement of A, which we call A prime, is the case that A does not happen. Here, A prime equals rolling an even number on a die. So the probability of A not happening, which is rolling an even number, is 3, because there are 3 even numbers, 2, 4, and 6, over the total number of sides on a die, which is 6. And that gives us 1 over 2. So therefore, the probability of A happening is 1 over 2, plus the probability of A not happening, the complement of A, is 1 over 2. And 1 over 2 plus 1 over 2 is 2 over 2, or 1, or 100%, we might say. On the Venn diagram here, we could call this the A, getting an odd number, is 1 over 2, and A prime is 1 over 2. And notice that the sum of those two equals 100%, which is the total sample size. Now I want you to be careful when you consider the complement of an event. So complement of winning, you might notice that the probability of winning plus the probability of losing does not always equal 1. And why is that? Well, in some games, in sports, we have the opportunity to have a probability of getting a tie. Okay? And so there might be a chance that 2 teams tie. Often soccer matches end with a tie. So it'd be better to write the probability of a win plus the probability of not winning, the complement of winning, that will equal 100%, or 1. Odds is another way of showing probability. It allows you to express a level of confidence about the outcome of an event. It is best to use odds when the probability of an event, A, versus its complement, A prime, is very important. So odds in favor. Odds in favor of A is the probability of A to the probability of the complement of A. Or we could say it's the number of events in A to the number of events in the complement of A. Odds against A is the reverse of the odds in favor. So here we have the probability of A not happening to the probability of A happening, or the number of ways of A not happening to the number of ways of A happening. That may seem a little confusing. Let's look at a couple examples here. So example number 1. What are the odds in favor of drawing a king from a deck of cards? Okay, let's scroll down. Take a look at a deck of cards here. So how many kings are there in a deck of cards? So here we have that there are, right here, these are the 4 kings. And in a deck of cards, this is something you'll want to know, there are 52 cards. So in other words, this other section here is 48. There are 48 non-kings. There are 4 kings. So, if we go back to that question, what are the odds in favor of drawing a king? Well, the number of kings to the number of the complement of kings, which are the not kings, would be, well, there are 4 kings, there are 48 not kings. And we simplify this much the same way as we simplify a fraction. So we look for something that's a common factor of both. So both of these numbers are divisible by 4, so we have 1 to 12. And that would be our final answer. We don't get rid of that 1 when we do a ratio representation. We want to understand that there's a 1 to 12 chance. Okay, what are the odds against drawing a diamond? So here we're looking for against. So we're going to look at number of not A. So the number of ways of a diamond, the complement of getting a diamond, to the number of diamonds. All right, let's scroll down again to our cards. Okay. And we have that right down here on the bottom row are our diamonds. And there are 13 cards right there. Okay. Again, there's 52 cards in a whole deck of cards, which means the rest here is 39. Okay. So how many not diamonds are there? There are 39 not diamonds, and there are 13 diamonds. Let's go back to that question. So we have that there are 39 not diamonds. There are 13 diamonds. And both of these numbers are divisible by 13. So we have a 3-to-1 ratio. And that makes sense because when you look at that deck of cards that we were looking at, there are 3 rows of not diamonds and there is 1 row of diamonds. So it's 3-to-1. The probability from odds, example number 3. The odds in favor of Shirley having lost her handouts are 8-to-1. What is the probability that she lost them? All right, so this is the probability. So number of ways that she lost them is equal to 8. The number of ways that she has not lost them is 1. So that gives us a sample size of 9, because 8 times she lost them and 1 time she did not lose them. So a sample size of 9, 8 plus 1. So what is the probability that she lost them? Well, there's 8 ways she would have lost them, and the sample size was 9. So it's 8/9. Now I kind of made a jump in the conclusion here. Her having lost her handouts was 8-to-1. It could have also been 16-2, because that would have simplified to 8-to-1. But notice that it doesn't really matter if we were to look at it as 8-to-1 or 16-2 or 24-3. In all ways, once we simplify it, we would still come up with an answer of 8-to-9, because the ratio would remain the same and therefore the probability would remain the same. So in general, if the odds in favor of an event A is equal, the probability of A is equal to H over, odds in favor of an event are H over K, then the probability of A is H over H plus K. So example, the odds in favor of passing this course, this is a grim example here, is 5-2. I hope it's better than that for you. What is the probability of passing? Okay, so you can think of this as being, what you can imagine, 5 people pass and 2 people fail. So that would mean the probability of a pass is equal to 5 over, and that would be 5 plus 2, which is this part of the probability. So that would be 5/7. So there is a 5 in 7 chance that you would pass this course. Now I've noticed when I do these questions that it's quite difficult to do questions in ratios. And when questions get quite intricate, I find it best to do my work in fractions with probability and to convert my final answer to odd. So let's do an example of this. For example, what are the odds in favor of winning Tim Hortons twice in a row if the probability is 1/7? So the probability of 2 wins is equal to the probability that you win and then you win again. And notice that these 2 events don't affect each other. Just because you went to Tim Hortons and you got a winning cup doesn't really mean that the next cup is affected, because the ratio remains the same, or probability remains the same. That's 1 in 7 each time. So the probability of a win is 1/7 and 1/7. which is equal to 1 over 49. So not very likely. It's a little greater than 2% chance. Okay, so once I get my final answer in probability, I'm going to convert to odds. Okay, so the question really was, what are the odds in favor? So in favor means start with a positive. So it's a probability of 2 wins to the probability of not 2 wins. Okay, and notice that that would include having 1 win only or no wins. So that would have more than just one option in there. So the probability that you have 2 wins is 1 over 49. And we know that everything that is not 2 wins would be 48 over 49, because that was every other option. Now what we can do is, because it's 1 over 49 to 48 over 49, we could multiply both sides by 49, and that would essentially just remove that, the 49s from both sides, and we would have a 1 to 48 chance. Which makes sense for those of us who have done Tim Hortons Roll Up the Rim and now converted to a digital version. That, yeah, maybe 1 in 50 years of your first 2 tries might be a win. And we got to talk about the first 2 tries, not in the middle of your options. It gets a little bit more confusing that way. Just to bring this into a bit of practical situations in terms of what happens in the real world when you bet on animals and things like that. So if you're winning with betting, how? Well, first of all, don't play. Generally, all betting is set up for you to lose and for a company to make a little money on the side. There's a chance you can take a little bit of profit, but mostly they rely on the law of large numbers, and therefore they're taking more money than they're going to be giving out, and that's why these businesses do so well. So don't play. But just to understand it, let's say horse A has odds in favor of 1 to 5, and I put $10 down on horse A. How much do I earn if horse A wins? Well, there's a 1 to 5 odds of my horse winning, which was essentially, it's more likely that my horse loses than it is that it wins. And so I'm pretty happy when my horse actually pulls together a win. And because my horse only had a 1 as its ratio, we would take this and go, well, that's 5 times 10, which is $50. And so you would get $50 of profit for having put money in on that horse. Now, there'd probably be some side fees on this kind of thing, but essentially your walk away should be $50 if no one else is gaining from your loss in your bet. This concludes our short lecture on odds.